Hello, Year 10. Today we are going to be solving simultaneous equations using elimination, but let's quickly recap the substitution method that we used last lesson. With the substitution method, you want to make sure that one of your equation has one of the pronumerals by itself. So the y is by itself in this second equation. So I'm going to take the y is equal to x plus 4 and sub it in to the y in the first equation. So we're going to call this equation 1, this one equation 2, and we're going to sub equation 2 into equation 1. So rewriting equation 1, we get x minus 2, open brackets, and replace the y with the x plus 4. Then that is equal to negative 7. Then we solve. X minus 2x minus 8 equals minus 7. Collecting like terms, x minus 2x is minus x, minus 8 equals negative 7. Adding 8 to the other side, we get a positive 1. Dividing by negative 1, the answer for x is negative 1. Then we need to still find out what y is equal to by substituting back into one of the original equations. So I'm going to substitute into equation 2. So we get y equals x, which is negative 1, plus 4. Negative 1 plus 4 is equal to 3. So that means that my solution as a coordinate, x is negative 1 and y is 3. Okay, so that was last lesson. Today we want to do the elimination, which is another method for solving simultaneous equations. It's an algebraic method again, and in this one we want to make sure that the x terms or the y terms have the same number in front of them so that we can either add or subtract to get them to eliminate. So, things to remember. First of all, make sure that the equations are set up properly before starting, which means that you want them in the same position. So whether that's x, y's equals number or x, y's constants equal number, both equations have to be in the same order. Then compare the two equations. We want the same coefficient in front of the x terms or in front of the y terms. We don't worry about plus or minuses. As long as they both have a 5 in front of them, for example, they both have the same number, then we'll be able to use the elimination method. Then, third step, if the terms that have the same coefficient have opposite signs, so one's a plus and one's a minus, then you add the two equations together. But if the coefficients have the same signs, then you want to subtract to make them cancel out. Once you find the value of one of the variables, then you substitute back into one of the original equations to find the other variable, and you can always check your answer by substituting into the original question to see if they work. Okay, so here's the questions. Solve each pair of simultaneous equations by using the elimination method. So when I look at this, I can see x and minus x. They both have a 1 in front of them. One's a positive 1, one's a negative 1. So those have the same number in front, whereas the y's are different. So I can't eliminate the y's, but I can eliminate the x's. Because one's positive and one's negative, if I add the two equations, so I'm going to do it as a big sum. So that's my line there is for like a big sum that you might have done in primary school. I'm going to add these two equations, got the plus sign on the side there, and I'm going to work down the columns. So x plus a minus x makes no x's. They'd cancel out. Then I move on to the y's. 3y plus 5y makes 8y. Then 7 plus 9 makes 16. The x's are eliminated and I can solve for y. So dividing by 8, I get y is equal to 2. Then I sub back into one of the original equations. So I'm going to sub into the first equation, so this one here, equation 1, which would give x plus 3 times 2 equals 7. 3 times 2 is 6. Subtract the 6 over to the other side and we get x is equal to 1. That means our solution is 1, 2. All right, we've done it once. Let's do it a few more times. Question B. The x's, one has a 5 and one doesn't, so they're not the same. But the y's both have a 2 in front of them, so they can be eliminated. Because they are both positive, I need to subtract those equations to make the y's cancel out. So let's do that. Minus 5x minus x makes negative 6x. 2y minus 2y is nothing, so they're eliminated. Minus 11 minus 7 is minus 18. Divide by negative 6 and we get x is equal to a positive 3. Okay, sub back in. Let's sub into, let's go into equation 2 this time. So that one there is going to be equation 2. It just looks a little bit nicer. So that's going to be 3 plus 2y equals 7. Subtracting 3, we get 2y equals 4. And dividing by 2, we get y equals 2. Therefore, point of intersection is 3, 2. Okay, question C. The x's are different and the y's are different. So if this happens, then we're going to have to multiply one, or sometimes you have to multiply both of the equations to make the x's or the y's the same. So I could multiply this whole first equation by 2, which would make that 6x at the beginning, which would be the same as the second equation. So let's do that. 3x times 2 is 6x, 2y times 2 is 4y, and 19 times 2 is 38. So make sure you multiply each term. The second equation, I'm not going to do anything to, so I'm just going to rewrite it. Okay, now to eliminate the 6x's that we have here, they're both positive, so I'm going to subtract the equations to make them eliminate. 6x minus 6x is nothing, they cancel. 4y minus 5y makes a positive 9y. 38 minus 7 makes a positive 45. Divide by 9 and we get y is equal to 5. Let's sub back in, and we can sub into any of the 4 equations. It could be the 2 original ones or the ones underneath. Let's just go into equation 1, the very top one up here. So that would be 3x plus 2y would be 2 times 5 equals 19. 2 times 5 is 10, so we have 3x plus 10 equals 19. Subtract the 10 and we get 9. Divide by 3 and we get 3. The solution is 3, 5. Question D. The x's are different and the y's are different, and unfortunately, the only way to get them the same is to multiply both equations. So I could multiply the top equation by 3 and the second equation by 5, and that would make the x's both 15x. You could also have done the y's if you'd wanted to. You could have multiplied the top one by 2 and the bottom by 3, and that would have then eliminated the y's. But let's keep going with what I've set up here. Let's times through those brackets. 5 times 3, we have 15x, then minus 9y equals 18. Timesing the 5 through the second one, we get 15x minus 10y equals 15. Okay, setting up the big sum, they're both positive 15, so we're going to subtract those equations. 15 minus 15 disappears. Minus 9 minus 10 means plus 10, so that's just y, or 1y. 18 minus 15 is 3. sub into, and we have to choose something to sub into. Let's sub into that equation. We'll call that one equation 2. So sub into equation 2. So that would be 3x minus 2 times 3 equals 3. 2 times 3 is 6. And now solving the equation. 3x equals 9. Dividing by 3, we get 3. And the solution is 3, 3. Okay, on the last page for today, we have a word question. So in this one, we have to read very carefully to try to make the equations and then solve them using the elimination method for simultaneous equations. So let's read through. A teacher buys 5 of the same chocolate bars and 2 of the same ice creams for $18, while another teacher buys 4 of the same chocolate bars and 5 of the same ice creams for $28. Determine the individual cost of the chocolate bars and ice creams. So we get to choose some letters to use for this equation. You could use C for chocolate bars and I for ice cream. I don't really like using I for ice cream though. So I think I'm just going to stick with X and Y. So the chocolate bars, I'm going to call X. And the ice creams, I'm going to call Y. So let's read through again and write down the equation as we go. A teacher buys 5 chocolate bars, that will be 5X, and 2 ice creams, so 2Y, and that costs them $18, so equals $18. And then the second equation is going to come from the next bit. Another teacher buys 4 of the same chocolate bars and 5 of the same ice creams for $28. Okay, so we have our equations. Now we need to get them arranged so that we can eliminate something. Let's eliminate the x's again by multiplying the top equation through by 4 and multiplying the second equation through by 5. So I would get for the top equation 20x plus 8y equals 72. And then for the second equation, 20x plus 5y equals 28 times 5 is 140. Okay, so now these are the two equations where I'm going to do my big sum. Both positive numbers, so we're going to subtract them. 20x minus 20x is 0. 8y minus 5y is 3y. Oh, sorry, there should have been 2 there. Try that again. 8y minus 25y is minus 17y. 72 minus 140 is minus 68. Then dividing by minus 17, we get y is equal to a positive 4. Okay, sub back in to the original question. Which one will we choose? Let's go all the way up to our very first one, equation 1. So sub into equation 1. That will be 5x plus 2 times 4 equals 18. 2 times 4 is 8. Minusing the 8, we get 10. And dividing by 5, we get 2. Now, x and y were letters that I introduced to this question. So for a word question, you need to write your answer in words. So x represented the cost of a chocolate bar. So we're going to say cost of chocolate bar is going to be equal to $2. Whereas the cost of an ice cream is equal to, what do we find out? $4. Okay, so a wordy question, please make sure you write your answer in words so that it makes sense. Okay, your turn to work on exercise 1J.